This is section 3.8, Implicit Differentiation. And in this video, we're going to go through an example of how to find the equation of a tangent line using implicit differentiation. So this is number 55 in your book. It gives us this equation, and it gives us the point 1, 0. So remember, if we're finding the equation of a line, of any line, we need two things. We need the slope, and we need a point on the line. When we're finding the equation of a tangent line, we find the slope by finding the derivative of the function, and they give us a point. Convenient. Okay, so let's go through how to find the derivative of this function. So remember, implicit differentiation, we use that whenever we can't isolate a variable on just one side of the function. So here, if we try to solve for either x or for y, we wouldn't be able to isolate either one. So we do something called implicit differentiation. The way I like to think about that is you take the d over dx, or you take the derivative of each term in the function. So here I get the derivative of x squared is 2x times the derivative of x with respect to x, dx over dx, plus, same thing here, derivative of sine y is just cosine y, and using chain rule, you go into your innermost function, which is y. The derivative of y with respect to x is dy over dx, equals, on this side, I have x times y squared. I have the product of two functions, I'll need to use my product rule. Product rule tells me to do first times the derivative of the second, which becomes y squared, bring down the 2, becomes 2y times dy over dx, plus the second function, which is y squared, times the derivative of the first. The derivative of x is just dx over dx. Okay, plus 1. That one's easy. Derivative of 1 is just 0. Alrighty, from here, my next step is to isolate my dy's over dx's onto one side of the function. But first, I'm going to clean this up a little bit. Remember, whenever I have a dx over dx, that's the same thing. That just becomes 1. So I have a dx over dx there, I have a dx over dx here. Cross that out, that becomes 1. And now what I want to do from here is get my dy's over dx's onto one side of the function, or one side of the equation. So I'm going to subtract this whole quantity over to the left side, and I'm going to subtract this 2x over to the right side, so that I have all my dy over dx terms on one side of the function. So on this left side here, I have cosine y times dy over dx. And remember, I subtracted this part over. So now I have minus x times 2y dy over dx equals, on the right side, I still have this y squared term. And I subtracted this 2x over. So I have y squared minus 2x. All right, from here, remember, we're solving for dy over dx. So I'm going to divide that out of this left side, and what I'm left over with is just cosine y minus 2xy equals, right side hasn't changed, y squared minus 2x. And now I'm just going to divide this quantity over to the right side. So I'm left with dy over dx is equal to y squared minus 2x over cosine y minus 2xy. Alrighty. So all of that led to this. This is the slope of our function. But remember, they gave us an actual point that they're interested in. They're interested in the point 1, 0. So we can find the slope of this function by plugging in 1 wherever we see an x and 0 wherever we see a y. So let's solve for the slope at this point. When we plug in 0 for y, we get 0 squared minus 2 times x, or 2 times 1 just gives us 2, over cosine of y. Cosine of 0 is just 1, minus 2 times x times y, that'll end up just being 0. So our slope becomes minus 2 over 1, or just negative 2. Okay, so here's our slope. It is just minus 2. And the point that they gave us is 1, 0. And now that we have our slope and our point, we can just plug that into the equation of our line and have the equation of our tangent line. So remember, there's a couple different ways you can find the equation of a line, but the one I'm going to use is the point slope form, and that tells us that y minus y1 is equal to m, the slope, times x minus x1. And from there, I just plug in my slope for m, plug in my x and y values, and get the equation of my line. So I'm left with y minus y1, which is 0, is equal to the slope, which is minus 2, times x minus x1, or x minus 1. And cleaning this up a little bit, I get y equals minus 2x plus 2. and that's your final answer for this problem. I hope you found this video really helpful. The concepts covered in this video are true no matter what calculus class you're in, but all the sections and problems I referenced were from this textbook right here. And remember that if you're a registered Baylor student, we offer free tutoring on the first floor of Sid Rich. You can either schedule a one-on-one appointment online or just drop in whenever you're available during our business hours for free tutoring. For more information, feel free to visit our website.